A very good day to my lecturer Dr. Mama Shmana, and today we would like to present about our rock physics project titled as AVO modeling of isotropic and anisotropic of reservoir X for different fluid types. And also our group members are Kishan Gopal Krishnan, Kamalasan Analaki Ganesan, Huganesh Analaki Chandru, and also Tineshwaran Analaki Udayakumar. Okay, now I will move on with the abstract. So the main purpose of this project is to investigate the AVO response of different fluid types of reservoir using isotropic and anisotropic synthetic models. It is done by plotting the amplitude of reflection versus offset AVO model. So basically in this study we will be reviewing an article entitled as Anisotropic AVO Analysis for Reservoir Characterization in Derby Field Southeastern Niagara Delta. Then the result of the model is compared with the real CDP gather to conclude the robust synthetic model for accurate AVO analysis in the field. In order to conduct this analysis, CDP process gather, Hampson, Russell, GeoView and also AVO module is used. The correlation of the anisotropic and isotropic synthetic model with the CDP gathers is done to compare the accuracy.
Isotropic direction is uniform, such that the physical properties of the material do not vary in different directions. In rock, changes in physical properties in different directions, such as the alignment of mineral grains or the seismic velocity measured parallel or perpendicular to the bedding surfaces, are forms of anisotropy. Anisotropy is a condition of a medium in which the character of the medium is influenced by mineral configuration, pores, fractures, or cracks. Thereby, the wave that propagating in the medium will be varied and dependent against angle. It is known isotropic direction is uniform, such that the physical properties of the material do not vary in different directions. In rock, changes in physical properties in different directions, such as the alignment of mineral grains or the seismic velocity measured parallel or perpendicular to the bedding surfaces, are forms of anisotropy. Anisotropy is a condition of a medium in which the character of the medium is influenced by mineral configuration, pores, fractures, or cracks. Thereby, the wave that propagating in the medium will be varied and dependent against angle. It is known as seismic anisotropy, and it's the variation of seismic wave speed with direction. There are several kinds of anisotropy medium, and in this study, anisotropic medium that is transversely isotropic medium with vertically aligned (VTI), which relates to distorted structures, and horizontal symmetry axes are known by horizontal transversely isotropic medium (HTI), which relates to fracture permeability. Simply, in horizontal transverse isotropic medium, we assume the fractures is vertically aligned. Isotropic medium has different characteristics with an isotropic medium. One of them is Thomson's parameter that influence the characteristics of anisotropic medium, and we can't find Thomson's parameter in isotropic medium. Reflectivity of P wave that propagates in anisotropic will be different with reflectivity of P wave from isotropic medium. Therefore, to characterize the reservoir with fractures, there is a need of different methods so that the fracture and its parameters in the reservoir could be appropriately characterized. By performing the pre-stack time imaging in the common offset vector domain, offset and azimuth information is preserved, allowing for successful post-migration characterization of the azimuthal anisotropy. In addition, both vertical transversely isotropy and horizontally transversely isotropy can be incorporated into the pre-stack time imaging, resulting in improved imaging. In figure 5a, data from a wide azimuth lens survey are imaged with a conventional pre-stack time imaging and an isotropic velocity field. Figure B shows the same data imaged with an azimuthally anisotropic pre-stack time imaging, also incorporated a vertically transversely component. The imaging of the steep dips is clearly improved as the imaging of the flatter reflections, mostly due to the incorporating the azimuthal velocity variation.
Hi, I am Tineshwaran. As my part, today I am going to talk about the reservoir characterization by AVO modeling. The first slide, introduction of AVO. AVO is the analysis of reflection amplitudes as a function of incidence angle. AVO is seen on seismic data due to the contrast between the elastic properties of the rock beneath the Earth's surface. From From AVO analysis, the interpreter could determine the significant parameters of the reservoir, such as the thickness, porosity, density, velocity, lithology, and fluid content of the rocks. AVO is also known as a direct hydrocarbon indicator. Why CDP gathers is used? They try to collect all the signals from subsurface and the condition will be same. Moving on to the next slide, AVO classification. The table shows the classes of AVO, relative impedance, and the amplitude versus offset. In right hand side, there's a graph shows amplitude versus offset. Moving on to the next slide, AV modeling. The modeling would be carried out by using well logs, which are the compressional and shear sonic velocity log and density log. These logs would be corrected to remove unnecessary data such as spikes and washout. Therefore, quality control of the logs is very important because they represent the reservoir and the neighboring rocks. Compression and shear wave sonic velocities and density logs would be used to construct realistic models for predicting the seismic AVO responses to the fluid in filling the pores. Lastly, there are few assumptions should be made during modeling. The normal and tangential stress are continuous across the reflecting interface. The normal and tangential displacement are continuous across the reflecting interface. These consequences, the two media in contact are welded, no slippage and pulling apart at the interface. Seismic waves are considered plane waves and not spherical waves. Thank you.
Greetings to all. My name is Kishan, and I would like to talk about the methodology, result, and discussion of this project. Throughout this project, the software called Thomson Ruffles have been used. First of all, I would like to talk about the CDP gathers. We should come up with the CDP gathers. The 3D pre-stacked PVF seismic data and well logs from Derby well were used throughout this analysis. The pre-stacked 3D volume was processed into common offset stack in which each trace represents a range of offsets. This form of average CDPs to enhance the signal to noise ratio while maintaining the AVO amplitude information of the gathers. We should come up with the well log data. The well log consists of sonic log, gamma ray log, density log, true formation log, caliper log, and check shot data. These logs were corrected for shale washout effects and despite using median filter to remove high frequency noise and other borehole irregularities. Well log analysis was carried out and three prospective reservoir zones were identified such as HD1, HD2, HD3. Okay. However, for the purpose of this study, HD1 was used for the anisotropic AVO analysis. Next, we shall move to the correlation of data. Well log data was check shot, corrected, and correlated with the CDP gathers. As you can see, the figure shows the well log correlation window showing synthetic trace in blue, composite trace in red, and CDP gathers in black, and then further followed by the statistical extraction of statistical wave in zero phase. Okay, let's move to the result and discussion. Presentation of results. The diagram on the left shows the AVO gradient analysis along VGI seismic horizon on anisotropic synthetic seismogram, while the diagram on the right shows the AVO gradient analysis along HGI seismic horizon on an isotropic synthetic seismogram. So based on the results, it is concluded that the reflection coefficient AVO for isotropic and anisotropic synthetic models at zero offsets are negative and close to zero for both models, but shows opposite AVO response with increasing offsets. The isotropic synthetic model shows decreasing amplitude with the offset compared to the increasing amplitude for the anisotropic model, which matches the real CDP seismic gathers. The results are similar at near offset and differ at far offset is attributed to the increasing contribution of anisotropic to the AVO response with offsets. The contrast in these anisotropic parameters across the interface controls the AVO response of reflected P wave, comparable to the real CDP gather but which differs from the isotropic case at larger offsets. Results also highlights that the anisotropic synthetic model and CDP gathers have the negative AVO product while isotropic synthetic model have a positive AVO product. The positive AVO product agrees with the anisotropic synthetic and real CDP gather is due to the negative AVO intercept and positive gradient arising from the low impedance contrast of the gas sand with overlying shale. Okay, that's all from the result and discussion. Thank you.
Okay, so in conclusion, we know the results of the anisotropic synthetic model correlated well with the CDP gathers, indicating that seismic anisotropy is an important element in the AVO analysis. Besides it, The result of this analysis clearly indicates that the description of the rock, without accounting anisotropy and seismic interpretation, is incomplete since most of the rocks are not completely isotrophic. So in a nutshell, taking seismic anisotropy into account will ensure that the correct Earth model is predicted and the reservoir is accurately characterized. Thank you.